high they are and which way they go. They pass every 90 minutes or 2 hours or whatever. In 2017, AMSAT is planning to launch a geosynchronous satellite, which is quite an event. It means that it will be up there staring at the Earth for 24 hours a day. And depending on who you believe, you'll be able to access it with a handy-talkie and talk to the world. Well, half the world, since you'll be staring at it. In preparation for that, AMSAT is developing a network of ground sites that are going to simulate two things. First of all, they'll be simulating the control mechanisms for the satellite. If you've ever operated a satellite on the operations, and I'm not talking about talking through the satellite, but if you ever managed the health and welfare of a satellite, it is a complicated endeavor. I've done it on different kinds of satellites, but the routine is no different. So they have to simulate that and prove that they know how to use it. And then they will also be simulating how the satellite responds. Hams will be able to use the network to think that they're talking on the satellites. So Palomar is going to host one section of a node. And tonight we're going to have a presentation by Michelle, by Phil, and by Mark on all of that. And it's going to cut out the BS I just gave you.
Thank you, Charlie. This presentation is specially made for PARC. It's called 4 on 4. Phase 4 on November 4th. If we had managed to find a fourth person, it would have been 4 on 4 on 4. Phase 4 is a digital geosynchronous mission on the microwave bands. It's made possible by a partnership between 3 pretty big organizations. If you've ever tried to get anything done with just one, you know how difficult it is. In our case, Virginia Tech, AMSAT, and Millennium Space Systems are making this mission possible. The phase system that AMSAT uses, it's a way to separate the different types of missions. Phase 1 mission is a test bed. It's a very simple satellite in orbit. It doesn't have very many capabilities. It just allows you to do some testing, essentially an orbiting test bed. Phase 2 is LEOs. Phase 3 has a more complicated or elliptical orbit. Phase 4 is what we are, which is geosynchronous. And Phase 5 is lunar or planetary. The Phase 4 project is done in close coordination with Phase 5 or Ascent project that AMSAT is also doing. There's going to be a lot of sharing between the two teams. Phase 4 is not just a satellite project. So one of my sort of secret missions inside this mission is to make sure that the radios and equipment and the development platforms are also used for terrestrial microwave to make the terrestrial bands really super fun. All of the advances that we're working very hard to do on Phase 4 are going to be able to be used in a terrestrial way as well. The reason that we're doing this is because there's lots of hams that would like for the microwave bands to be easier to use. And there's lots of microwave enthusiasts that aren't into satellite. We would like to reach everybody. This is a quick diagram of what a Phase 4 system would look like. You can see that there's lots of yellow arrows going up. That's your uplink, up to the satellite. What we've decided to do is FDMA, or frequency division multiple access up. Everybody has their own frequency band within the 10 megahertz bandwidth. It's one big fat band down, and it's a TDM, or time division multiplex. You can see along the bottom we have 3 different radios. The bands are on this slide. Another use case is you still have these individual stations on the uplink, but you have a different station that aggregates local traffic. We call it an ARAP, which is an amateur radio access point. This gathers up either emergency traffic or local traffic aggregates it, beams it up to the satellite, so that if you have an HT or a P25 radio, you can talk through the satellite to anywhere in the world. If you're familiar with like a WiresX or System Fusion, then this is very similar. Another use case is that the Phase IV radios talk to each other terrestrially while they're connected to the satellite, or instead of connecting to the satellite. What we're trying to do is make microwave mesh radios out of the Phase IV radios. Those are the 3 main use cases that we're targeting. So who else is directly supporting this project? Well, you know, being a space project and totally new radios, we need a lot of help, and we got it. PARC is helping. Escondido Amateur Radio Society is helping. The Dixon Lake Recreation Area has volunteered to host an ARAP. Rincon Research has donated a very powerful SDR for the satellite. The North Texas Microwave Society is hosting another GroundSat and ARAP pair. FEMA has given us basically orders to make it work for emergency services and have been directly supporting the project with a lot of advice and a lot of open doors. Edis Research has donated the USERPs. These are very powerful SDRs that you see in labs. We're going to be able to develop both the GroundSat, the satellite simulator, which will go on Palomar, and the ARAP and the handsets using equipment that he donated. Hume Center at Virginia Tech is very involved in space stuff. They are directly involved with the project and supporting us with GNU radio waveforms. And ARRL is supporting us as well. There's now several MOUs going in all different directions. I did not draw a slide with all of that stuff going on, but a memorandum of understanding between all these organizations is working its way through. Besides all these organizations and TLAs is lots and lots of volunteers. And that's really the power of this particular project, is the number and type and quality of volunteers that we've been able to very luckily attract. So our current status, we have about 40 volunteers that are active. Some of those volunteers are also employees of some of the companies that I mentioned. We have paid for or raised the money for a $100,000 rideshare payload study at Millennium Space Systems. Millennium Space Systems is the integrator for the mission that we are getting a ride with. We're expecting a late 2016 or early 2017 launch. I'm going to be betting on the 2017, and I really hope that we get that extra time. We have about 100 watts of power from the spacecraft. This is huge. We will enjoy access to the cold plate. Technical space stuff for like cooling is really difficult in space. We get to attach ourselves to the cold plate. We can use several external areas on the spacecraft for antennas. We do not have to control the spacecraft. We are not in charge of station keeping. It's the Air Force's project. We get a power plug and they can shut us off if something goes wrong. Everything else is handled by people that really know what they're doing. Now I have to say that this is good and bad, because having an amateur satellite service that knows how to do station keeping is actually very important. Fortunately, we have a lot of other satellite projects going on. So this is not something that's going to go away in AMSAT just because we get this awesome opportunity here. Ground station development is completely open source, meaning you get to see our process, mistakes, code, backtracking, forward tracking, side tracking. We're going to do it all transparently. The space segment development is ITAR controlled. Does anybody know what ITAR means? Okay, so yeah, the space segment stuff is ITAR controlled. Here's a possible satellite footprint. I have a slide for that. I do. Yes, sir. Oh, I don't know how. I can try. How hard do you want me to hit it? And where to hit it? Focus. You notice Phil is not wearing glasses. It made you look. Or do you want to make it bigger on the screen? Over here? Over here, Phil. Over here. Do you want to make this bigger?
Did you do a full screen?
I don't know how. It's your.
Okay, let's see, view slideshow.
Cool. Okay, is that better? Okay, cool. The mission from the Air Force is going to be out at, oops, Okay, it's going to be at 74 degrees west to start out. All right, so here's the connections that got us here. The wide field of view is the name of the mission from the Air Force. The MSS, Millennium Space Systems, is the integrator. Jeff Ward is the CEO there, and he taught at the University of Surrey. Colonel Fred Kennedy in the Air Force was his student. Here we are at Millennium Space Systems. That is what our satellite looks like. All that stuff on the top that looks like a city, those are their antennas and their special camera. Cool, huh? Here is the connections with Millennium Space Dev, or Millennium Space. It's actually Space Dev Connections, which is another company. So you can see Space Dev, which built ChipSat, has lots of people that are involved now at MSS and AMSAT. Then RingCon, the people that are donating the cool SDR on the spacecraft, well, these are their connections. And you might recognize some of these people that are also at AMSAT and TAPR. So, ITAR stands for the International Traffic in Arms Regulations. It directly affected this project. When we started work back in April, we were trying to do it all as one big team, the space segment and the ground segment, which we wanted to also use for terrestrial microwave. And we started running into a lot of problems right away. ITAR prevents you from sharing certain information outside of the United States. You have to keep it under your hat, or you'll get in big trouble with the State Department. Trying to do an open source project with ITAR controlled stuff is a huge challenge, and it turned out to be too huge of a challenge even for us. So what did we do? We decided to do something by splitting up. We decided to split off the ground people onto one team, and that's my team. And the space team, they can go someplace else. I hate space. They can go away and figure things out on their own. So how do you coordinate these two teams? Well, it's called documentation. So now we have a space team up here, and we have us down on the ground. Here's Bob putting up some equipment, and we communicate through a document called a common air interface. An air interface document defines what goes through the air, and never the twain shall meet. Our common air interface gets to be open source if we're careful. All the space stuff gets to stay hidden, ground stuff gets to be open source. This is what our ground team looks like right now. It's a highly organized team of cats that are all currently facing the same direction. And they really are awesome. There's 4 big sections of work. And we're trying to get everybody to go in the same direction with the same arrows. As you know, it's hard. RF hardware, we have a 5 gig up and a 10 gig downlink. We have antennas that we have to build. There's all sorts of applications. When you run your Phase IV radio, you'll have lots of choices. There's servers, and that your radio is actually a computer running servers. The 3 servers that we're planning on you having are XMPP, YAWS, and an authentication server. And then there's a ton of digital hardware. So these are all the things that the team is doing. And here's the people that are helping. It's me, it's Bill Reed, it's Jerry at AMSAT, and it's Bob McGuire from VT. The way that it's working so far, we just solve problems by working it out and talking back and forth and getting the team to move forward. Our development system is 3 big chunks. There's the ground sat, which takes the place of the satellite. And it's usually, figure it's going to be on a mountaintop or a tower. That's what PARC is hosting. The ARAP, or Amateur Radio Access Point, that's the one that aggregates the signals. It can move around or it can be fixed. And Dixon, the Dixon Lake area, is going to host that, and Escondido Amateur Radio Society people are interested in helping there. That's actually going to be probably the most challenging software to write. The user terminals, those are the Phase IV radios. We need to build those too. The ground sat, like I said, going to be at on Palomar. That's a very happy looking ground sat. There's 4 sites total for ground sat across the US. So all these teams will be working in parallel. The difference here is that each of these sites, there's one in San Diego, one in Maryland, one near Virginia Tech, and one that the North Texas Microwave Society is going to put up. These were chosen based on like who would agree, who could get talked into taking the gear, but also we looked for places that had a very different geography and different weather so that we could get a variety of radio environments and challenges. And hopefully by having all of these development stations in these different areas, we'll be able to solve some problems with, oh, who knows what, weather for one. So this is the development platform for a ground sat. This is a USERP X310. It's a universal software radio peripheral. So when I say USERP, that's all those words together. It's just a fancy SCR. You tell it what to do and it makes the waveforms for you. It's here, by the way. It's right in front of Mark, so you guys can see it. The ARAP, Amateur Radio Access Point, is this is our logo. The logo is built, has a puzzle built in. It's a cryptographic puzzle. I brought stickers. Mark, if you want to take one and pass it down. And if you can solve the puzzle and send what it stands for, send me the answer, then you get a patch. All right, the ARAPs aggregate the radio traffic and they send it up to the satellite. The goal is for people, especially emergency workers that have FM radios or Phase 25 radios, to use their own gear in an emergency, and we get the signals out. During a communications emergency, if we need to control access to the satellite, the ARAP and other Phase 4 radios have shared secrets that are already on board, and they get activated during a declared communications emergency so that the uplink access to the satellite will be controlled. Here's what it looks like from the Dixon site looking up to Palomar. We're going to put a backhaul in. We have the equipment. This is the ARAP demo running. The first demonstration was made at AMSAT Symposium with handy talkies with FM radios in mid-October, and we repeated the demonstration once we got the equipment here on the 30th. The user terminals, however, you notice there's no real hardware here. There's still a block diagram, but we have a great block diagram. It's survived its first review. The operator sees applications, so we call it application space. The applications talk to servers. Servers talk to the modulators, and the modulators talk to RF hardware. Looks really simple, huh? Some of the potential types of hardware that a user terminal could be, the Phase 4 radio can be, are also here. There's blade RFs and hack RFs. The radios will have to be on the order of this powerful. So here's some contact information. If you would like to follow the project, we are on GitHub and we have a mailing list. You can contact me or the VPE at amsat.org. The space list and the space repository are closed. It's much harder to follow along, but if you're a US citizen and you have experience in any of this sort of design, especially RF design, either one of us would love to have you. We have a complaint department. It's located in Imperial County, and Dennis is the complaints lead. Now I'm going to hand it over to Phil Karn, and he's going to talk more about some of the technical aspects of Phase 4. However, I have a couple of minutes to answer questions if anybody has any sort of question about any of this. Oh, Kathy Boyd has joined us. Yes, she has. I see you. Kathy, could you please stand up? Thank you so much. She's another extremely active volunteer. She is a ranger at Lake Dixon and is totally responsible for us making a lot of forward progress out there. She's saying no. Should I take it back? Okay, I won't then. Thank you, Kathy, for coming. Yes, sir. Yes. No, there will be no encryption because we can't. Correct. Okay, the question was, will there be encryption? And the answer is no, because it's amateur radio. Charlie has a question.
Just out of curiosity for the folks, me included. Okay, so Palomar hosts the node. What am I capable of doing once the deal? Where do I fit into this picture?
Well, the typical club member, we need it to be tested. So you will get to operate on this ground sat. This ground sat stays here. If the satellite goes up and it blows up, the satellite goes up and stays up a year instead of the planned 4 or 5, since it's a test mission. Its lifespan is in the order of small numbers of years. This system stays, and you get to play around with and help build and contribute directly to the project as a user. So it's a microwave-based.
Can I anticipate using my hand talkie
That's what we are hoping to do that for you. Yes. You bet. We're motivated. There's a, oh, yes.
The satellites antenna is just covering U.S. and Canada, it looks like.
Yeah, the question is about the footprint, just covering the U.S. and Canada. Yes, to start out, you can try though. You could try. I'm saying that's our goal. I didn't say we would actually. Oh, but the parking orbit for satellites like this is over Australia. So once it's done collecting data, which it is supposed to be doing, the Air Force mission is to collect data, then they will eventually put it in a parking orbit. It'll be over Australia. There you go. Yes. Oh, I'm terribly sorry. He wanted to get DXCC. Quite possibly, because we're going to develop the ARAP, the Amateur Radio Access Point. That's a signal aggregator, so that you can use pretty much any radio that we're able to if we can get your signal and package it up. That's our goal. So that's a big goal, but that's the goal. Yes. Of course. The air interface is developed by all 40 of us that are working in concert with the space team, which is like another 40 people. So we're all working together to develop it. Correct. That's exactly right. He's asking who's developing the air interface. If it's being told to us, no, it's something we develop. The cost of the project, the $100,000 is for the Air Force to figure out that we're not going to screw up anything on their satellite. And AMSAT raised that at Hamvention this past year. It's a really huge chunk of change, I think. But the cost of the mission to us total is on the order of $5 million. All of this is going to come from HAMS, but it's also coming from the Air Force. It's also coming from MSS, lots of donations all the way around, from Virginia Tech, who has someone who's a full-time money raiser who's going to be working on this. It's a big, expensive project. There's a lot of risk. The things that I'm talking about tonight, we are really hoping that they're going to happen. We're all in. Some of us are working full-time on this project and are committed for the next year. If it gets canceled or delayed or whatever, then might not happen. It could blow up, as I said. Something could go wrong with our end of the deal. Something could go wrong with the Air Force's end of the deal. So to understand, space means risk. But we are working very, very hard to make this a very high quality, very good project for amateur radio. Yes, sir. We're hoping like very late 2016, early 2017. That's a question is about when will this actually happen? And that's when the launch is currently scheduled. Yes, sir.
Assuming the satellite is successful, will we be able to talk to it directly, or must we go through an aggregator?
No, you do not have to go through an aggregator. He's asking, can you talk to the satellite directly? Yes, we absolutely hope that you will. As long as you have a radio that the satellite understands. You can build your own if you want to. We're going to try very hard to build a bunch, at least 1,000 of them. And we'll also publish either kits or a do-it-yourself or whatever. So there's multiple levels of this. There's also a low data rate mode. So it's not just, a high power station with a big dish. There is a low data rate mode that's really quite exciting. That's what there's a whole sub team working on that. It don't require as much power, but you don't get as much bandwidth, and the coding is much longer. Actually, Phil is going to talk about that next. Yeah, he's got some very good data on exactly what you would need for a typical base for a higher power station. Any other questions before I hand it over to Phil? I'm sure we'll have time at the end to answer some more too. Thank you very much. Phil Karn is up next.
Thank you. Let's go back to the beginning here. Okay, Phil Karn, KA9Q. I'm going to talk more about some of the nuts and bolts down at the communication layers, which you can, you know, the choice of frequency bands we used, how big the antennas are, how much power you're going to need, you know, data rates, all that kind of stuff. So this is kind of a deep down view. Michelle is just giving you the overall view of the project, and I'm going to give you some of the details. But I do want to point out, this is more than just one satellite. The technology we develop here is not just for Phase 4. It can be used for lots of things. If the Phase 4 project, if the satellite, if the launch vehicle fails and it goes into the water, we won't have wasted everything. We can use this technology somewhere else. A lot of it is common, or will be common to other projects. Something about me, I've been at this now for a while. I've been a ham since 1971. I retired from Qualcomm 4 years ago. I've been very active in well, internet activities, internet over radio. I was very heavily involved in the early days of packet radio, and in a project called PACSAT I'm going to talk about, which was actually the inspiration for what we're going to do for Phase 4. So you'll see some ideas that are brand new and some ideas that have actually been around for quite some time. Michelle has already talked about AMSAT, so I won't really talk too much about this, except to say that they just had their most recent satellite launch just last month. AMSAT Oscar 85, Fox 1 was launched on 8th October. Yes, there's actually been 85 amateur radio satellites since the first one. To give you an idea how much has happened, my first satellite when I got involved in AMSAT was launched in 1983, and that was AMSAT Oscar 10. So there's been quite a bit of activity since then. In the late, I'm going to take a little back a little bit in history here because it will explain some of what we're doing now. Way back in the late 1980s, personal computers and packet radio were really starting to take off. We were having a very hard time, however, getting launches into high altitude orbits. We had the Phase 3 orbits, which were these elliptical orbits that we're getting from the Europeans on their Ariane launcher. 3 of those actually succeeded. AMSAT's Oscar 10, 13, and 40. One before that, back in 1980, failed when the launch vehicle failed. But we could see the writing on the wall, which is that if we were going to be launching a lot of satellites, we had to figure out something useful to do with low Earth orbit rather than higher altitude, which is much harder to get. So back in the late 80s, a bunch of us got together one night, very late night in a hotel room and kicked around this idea for what became PACSAT, or AMSAT Oscar 16, which was launched 25 years ago. The idea was proposed by Tom Clark, W3IWI, Bob McGuire and 4HY, who's now at Virginia Tech. So a lot of the same people were involved. Jan King, W3GEY, who was AMSAT's VP of engineering for a long time, and myself. The idea of PACSAT was that, first of all, we wanted things to be digital. The digital age was coming. Most AMSAT satellites, well, actually all AMSAT satellites up to that point had analog transponders. In other words, whatever you put in is what came out. If you put CW in, CW came out, single sideband, and so forth. But we had this idea of getting really aggressive with digital. We wanted to excite people what was possible with digital. So we came up with this concept of a flying mailbox with 4 separate uplinks on 2 meters, 4 different channels. They're all equivalent. You could just transmit on one at random and they would all be heard by the same computer. And there would be a common downlink on 70 centimeters, also running in a packet mode. So the overall project idea was a flying mailbox. This is, of course, before most people had email, so you could wait for the computer, wait for the satellite to rise over your horizon. You check in, you dump your email, load, whatever email you wanted to send, and it would fly somewhere else over the world, and then someone else could do the same thing. This idea has actually been commercialized. There's I think it's generally known as the Little Leos. I don't actually know how well they've been doing commercially, but this idea, in fact, was commercialized, as have actually been many AMSAT and amateur ideas over the years. This is a very simple block diagram of what PACSAT looked like. You see the satellite at the top. You see 4 uplinks in red. Those were the 4 channels in 2 meters. There was a common downlink on 70 centimeters, which all of them listened to. And because it was packetized, everything had an address, everything was framed, had an address. You could tell who the packets were addressed to. If a packet was addressed to somebody else, you could ignore it, or you could monitor if you were so inclined. So now we come forward to this year. We get the Phase 4 opportunity. Michelle has already talked about the details of what this opportunity is. They basically do all the hard work for us. This is an amazing opportunity. I'm still kind of pinch myself to see that it's real. I'm still trying to believe that it is real, because it's a wonderful opportunity we've been waiting for a very long time. Because all we have to do is provide the payload. We don't have to do any of the bus stuff, the problems of getting it there and powering it, pointing it, and so forth. They'll do all that for us, which is really quite a deal. So we were thinking, what could we do with this opportunity? Yeah, we could launch another linear transponder. We could do that, but that's kind of like, 20th century technology. We're trying to decide what we can do that's new and exciting and interesting. And today, of course, everything's going digital. Why not make a digital satellite that works somewhat like PACSat, but because it's in a high altitude orbit, does not have to work in a store and forward fashion. You can talk to it in real time. In other words, the satellite can repeat what it's hearing in real time. So you've only got the round trip delay up the satellite and back. What can we use this for? Well, I don't really want to use this as an internet replacement. I mean, I can't compete with the internet. All right. I don't really expect to do that. In an emergency, yeah, we have that capability, but we're trying to think of what can we do with this that we can't already easily do with the internet. And the one application is the one that every ham is familiar with, which is a big voice roundtable. That's actually fairly easy to do, and we can actually handle quite a few of those at once, and you'll see some of the numbers a little bit later. A lot of the technologies, the piece parts are coming together. VK5 DGR did a wonderful project several years ago where he did a voice compressor, which is actually better than many of the commercial vocoders out there. He did it specifically for ham radio to use. It's open source, it's free. It only requires a few kilobits per second to give very good voice quality. So all these piece parts are out there that we can pick from and plug together into making make this happen. I mean, all the time is right for this now. We can do medium speed data, but like I said, we're not really trying to compete with the internet. We don't have the capacity for that. Okay, so this looks an awful lot like the PACSat architecture, because it is. The main thing that has changed is the frequencies. As you can see, the uplink frequencies have now moved up to 5.6 to 5.65 to 5.67 gigahertz. That's the amateur satellite allocation on the 5 gigahertz band. And the downlink will be somewhere between 10.45 and 10.5, which is also the amateur satellite allocation on that particular frequency band. So once again, there's a common downlink that everybody listens to, runs at high speed. It's packetized, so every frame has an address, so or I should say your equipment knows whether it's addressed to you or to somebody else. But individual users transmit back up to the satellite on different frequencies actually at a lower data rate. The satellite decodes whatever it can, turns those packets around, and sends it back down in the downlink. So it's like it's a packet transponder, if you will. Multiple inputs and a common high-speed output. Now, if you're designing a satellite system as compared to a digital system for terrestrial, which is what I did before I retired at Qualcomm, it's all about terrestrial digital radio communications. Some things are easier and some things are harder to do on satellites. Some of the things that make it harder is that it's a long way up the geostationary orbit. It's about 1/4 of a second propagation delay. DC power is very expensive to generate in space. That's why this is such a great opportunity for them to give us 100 watts of DC is amazing. And computing up there always seems to be behind, because if you're going to put a computer in space, it's got to be reliable. It's got to be rad hard. It's got to have low power consumption and so forth. Now, Bob N4HY takes exception to this when he saw my slides last night. He thinks it's not really a decade behind. It really has been a lot of improvement recently in the hardware can fly, and it's not a decade behind. It's only a few years behind, and it's actually up to the task of what it is we want to do. But there's some things about satellites that actually make them easier than terrestrial. It's an easier problem to solve than your phone, and that is that it's a line of sight path. You can see the satellite. There's no multipath. Their signals are not reflecting or bouncing off of anything because it's up there in the sky and there's nothing around it. So there's also very little fading because the satellite is not moving. About the only fading you ever get on a satellite link of this type is when it rains heavily, because water absorbs microwaves. The higher you go in frequency, the more it will absorb. But all these things can be worked out. So this is one of the realizations we made way back in the PACSat project, which applies just as much now, which is that the uplink and downlink problems are different. And because we have a digital satellite, nothing says that we have to talk to it in the same way it talks to us. That would be true with a linear transponder, where it simply echoes back whatever it hears, the exact waveform. But because this is digital, because there's processing on the satellite, we can design the uplink to do the uplink problem well, and then we can design the downlink to do the downlink problem well. We can make them digital. We can make them digital. We can make them. We can optimize them for each task. The ground stations, of course, can't talk directly to each other anyway. They're spread across the country and don't have line of sight to each other. That's why they're using a satellite in the first place. In fact, this is very much like the way cable modems are designed. If you know anything about cable modems, you know that there's a high-speed downstream channel, which is running all the time, which sends packets out to everybody, and your cable modem picks off the ones that are addressed to you. And then when you need to send a packet, your cable modem transmits on a fairly low frequency in the upstream direction, and it has to contend with all the other cable modem users in that direction. So the job is actually very much like a cable modem. And in fact, we can even use some of the same concepts, some of the same modulation schemes will work. The downlink problem is actually the easier one. There's only one transmitter on the downlink channel, that is the satellite itself. Nobody on the ground is transmitting on that frequency. So there's no multiple access. There's only one transmitter, and it can just label each frame with who it's going to, and there's no collisions, no problems there. However, power efficiency is paramount. As I said, DC power is very expensive to generate in space, so you have to use it as efficiently as you possibly can. So our plan here is to have a continuous stream, comes down all the time at a fairly high rate, because all the user traffic will be going over this single stream. And we can use several off-the-shelf modulation methods that are actually very similar to what's been used on cable modems. In fact, they're simpler than what's currently being used on cable modems, with some of the error correction schemes that are become standard state-of-the-art in the industry now. So like I said, a lot of these piece parts are already available off the shelf, and many of us have experience in working with them in our professional lives. This will probably not be readable. I just put this up to show that with satellites, you can plug in numbers and get results that are actually very repeatable, because everything's line of sight. Physics really works. The physics are clean. If you know how much power you're going to transmit, how big the antennas are, how far away you are, and so forth, you can say exactly how strong the signal will be on the other end and how fast you can send data over that. So these are just some representative numbers. Again, the frequency band or the frequency is 10.5 gigahertz, which is about 3 centimeters. We're assuming an output power of about 40 watts, which seems like a lot, but I'm told that we can generate 40 watts of RF through a 20 dB gain antenna on the spacecraft, which is, it can't be any higher than that, because if it gets higher, it starts missing part of the Earth, and we want to cover all of the Earth from that altitude. And that's as high as you can go, is about 20 dB. On the ground, I'm assuming, and this is an important number, a dish that is 66 centimeters in diameter. It's about the size of a DirecTV dish. In fact, it could actually be a modified DirecTV dish. We're assuming that's actually what it's going to be, is a DirecTV or dish type TV dish, because the 10 gigahertz band is actually fairly close to where DirecTV operates. We think we can probably modify them and do quite well. So the bottom line from all this is that, if you put in all the piece parts I talked about, we can get a 10 megabit per second data rate out of this thing continuously coming down from the sky. That's a lot faster than anything we've ever run, certainly from satellites before. The only thing that comes close to it is some of the mesh networking stuff using Wi-Fi, which is operating at data rates in the tens of megabits. But that's what we can do with a dish the size of a DirecTV dish. You can get a continuous 10 megabit per second data stream coming down from 40,000 kilometers away. I think that's pretty impressive. In fact, it'll behave very much like a DirecTV system. And I'm sure most of you either have or have seen DirecTV or Dish TV. They know how it works. This is going to be very similar to that. Dish is about the same size. Data rate's about the same. You point it about the same way. So this is not going to be all that new to a lot of people. Okay, the uplink, as I said, is a different problem. You've got lots of transmitters going up to one satellite. They're probably all transmitting a relatively low data rate. We want to share the satellite across a lot of users, so they can't each be sending 10 megabits. Our baseline application is simply good old push-to-talk voice, just like an FM repeater, actually closer to the point of a trunking system. So you're pushing the button, you talk, you let go, just as you do on FM. We can support some number of channels of these, but we have to make sure that the users will not collide with each other at the satellite, that somehow we're able to share the spectrum efficiently. One design point that we do have to worry about is that at least the RF guys are telling me that microwave power amplifiers are still fairly expensive. So we're trying to keep that amplifier as small as possible. And we're baselining a 1 watt amplifier on 5 gigahertz. I don't know how much that costs now, but I'm told it's a tolerable amount of money. And if they get cheaper, we can always make it bigger. But that is a design constraint. This is an uplink link budget. The main thing that's changed is we've gone to the 5.6 gigahertz band. We're assuming 1 watt transmit power in the same size dish, 66 centimeters, a DirecTV type dish. The beam width will be a little bit wider because it's lower in frequency, so it'll be a little bit easier to point. We're assuming a data rate of only 5 kilobits per second. So this is much, much lower than the downlink, but it's only for one user. And it could be many users transmitting at the same time, each transmitting a voice stream. But 5 kilobits is enough for voice using something like Codec 2 to actually sound very good. So these numbers are all subject to change, but these are like baseline numbers. These give you an idea of what we can do and what we can't do. And this will actually work with for about a margin. I mean, we could actually go faster than this or handle more users. But if you have a downlink that's carrying 10 megabits per second and an uplink carrying 5 kilobits per second, we divide them out. That's 2,000. We could handle 2,000 simultaneous voice QSOs or simultaneous people talking, which is a pretty good number. I don't think we've ever built an amateur system quite that large before. But this is the kind of thing that we can do. We just need to find applications for it. I don't want to go into a whole lot of detail, but just to give you a flavor of what the kinds of things we're working for that have to go into the common area interface that Michelle mentioned. Because everything is packetized, when you transmit to the satellite, you have to make the satellite able to first find your transmission, lock in on it, decode it, and figure out where it's supposed to go, who's coming from and where it's supposed to go. So the frame that you send might look something like this. When you push the mic button, it automatically sends this frame. And then as soon as you let go of the mic button, it stops sending these frames. So the header at the front would contain, would identify, you would have your call sign, it would indicate the data rate that you're sending, all the other details that the satellite would need to decode your signal. There might be an authenticator in here. Authentication was mentioned as one possible requirement by FEMA for emergency applications. I presume this would not be turned on unless there was an actual emergency, but it would be possible to turn on an authentication system so that only those who were authorized could actually get into the satellite. But I can't imagine that would be done except during an actual emergency, which makes sense to me. Okay, so what does the end user box look like? What would you actually see as the user? Well, here's my concept of a very simple baseline radio for this. It's just a box with a couple of knobs and a display that shows what channel I'm on. It can show you who is talking, which an FM repeater can't do now because every packet has its call sign of the transmitter in it. You can change channels, or you can say, I only want to hear somebody who's trying to talk to me specifically, or I can go to a group and have a roundtable conversation. And here's a little feature I kind of like. On the right-hand side, I've added a mute station button. So if there's somebody in a roundtable conversation who simply won't shut up, you can just push that little button and you mute him out. I mean, he can keep talking and other people can keep hearing, but you won't, because you're getting everybody's coming down. They're all being individually identified. They're not being summed in the satellite. They're all being sent back down. And it's up to you to decide whether you want to listen to it or not. So I thought that was just a cute little feature that is something you can't actually do right now in FM. But it's an example of the kind of things we can do. What we're really looking for are people to come up with really clever ways of using this. I like to think of myself as a guy who likes to build engines and transmissions. I'm not I don't design car bodies. Somebody else does that requires a different set of skills. I like to give you the basic piece parts so that you can build into a car, and it's up to you guys to figure out what to do with it. So that's why we're out here talking about this, because there's not much fun in building a system that nobody uses. We want this to get used. So that's it. Any more questions for either Michelle or me at this point? Yeah.
So that uplink, it's digital voice, but it could just as well be digital.
It could be anything. That's right. It could be digital data, but okay, what can you do with 5 kilobits or something on the order of 5 kilobits? You can do text, certainly. And we would encourage that. It would use less resources in the satellite. But voice is kind of like the baseline application. But you're right, because it's digital, it can be anything as long as it fits in that stream. But it's not going to be internet access. It's not fast enough.
He really likes voice, but I like voice memos that you can send off, like the WhatsApp. That's my favorite, and images and text. So this is a digital thing, and he can keep his voice, but I'm advocating for text. Yeah, anything that. Can you do CW? Absolutely.
We can simulate that.
Yes. Yes.
If you like, I can add software to like simulate QRM and QSB, and if you like, I can add that.
CW, and he has knobs on the radio.
Right.
So what modulation scheme again? When he sends it 700 hertz CW tone, how's it going to go PPSK or what?
Sure, but That's all details. That's all details.
Details. Oh, yes. Yeah. Well, I mean, we're figuring this out now.
Yeah.
You know, we have a good idea, you know, because a lot of the team has a lot of experience in this stuff. And it's like, well, there's a few modulation schemes that are going to work really well, and we're going to start working on those. And
Yeah, we're all just getting started in the project, but a lot of us have a lot of professional experience in these fields. So these technologies are already familiar to us. We just have to pick the ones and put them together we know will work.
yeah. Yes. Oh, yes, sir. That's
It's really up to the ARC guys, isn't it?
Yeah, it's the reason why we're raising the possibility that you might have two antennas on a phase 4 radio, is because building a dual feed for both 5 and 10 at the same time is actually pretty hard. And we're working on it. So we would really like to get this down to one antenna. And there's some very expensive antenna designs that will work. So it just kind of depends on whether or not we can swing it. Worst case, you'll have to have 2 different antennas.
You can do it for us, great.
I'm sorry, what?
Oh, sure.
Yes. The question was circular polarization with a question mark on the end, and we said yes.
So you're developing all this modulation scheme and all that, and because of ITAR, we can't share this with anybody in Europe or.
Oh, that's not a problem.
No, that's not. As long as we're careful. You want to answer that?
ITAR is a real headache, and the rules just changed. They relaxed quite a bit just this month. I'm not sure I know all the details of what they mean. And one of the big problems has simply been how vague they are. We don't really know what they mean. But there's nothing here that's going to be ITAR control. This stuff has been around for decades. Right. Okay, it's been used for decades. Right. And I don't, I intend to publish everything I do openly.
Yeah, he publishes everything. We're actually phase 4B. The phase 4A is made by the Germans. So it's 5 and dime is the nickname for this, 5 and 10 gigahertz. So these bands, AMSAT hopes going forward will become a standard set of bands for future satellites. One of the things we're trying very, very hard to do on this particular rideshare is do a really bang up good job so that we can get our own geosynchronous satellite to ourselves that's not a rideshare. So that's kind of the goal, is for this to be duplicated and with good documentation. And like he says, he's going to share everything. We're going to share everything. We want this to spread. We want to give it away. We're not giving away any secrets with the air interface or the ground station or anything like that. The real thing that we have to be careful with is anything that has the word spacecraft attached to it, icky space on it, then we can't, the development of it, we can't share. So that's controlled.
Hardware is one of the touchy things. Yeah.
But the Chinese and the Germans and who knows, the Australians, are they working on systems independent of this?
Well, I don't know about the Chinese, but certainly the Germans. I keep in touch with them, but we intend to publish as much as we can. But like I said, I think the only stuff that may be touchy is some of the space qualified hardware. That has to be that kind of hardware in order to survive in space. That's the kind of thing they tend to be touchy about. The stuff that goes over the air, the stuff that goes on the ground, that stuff, it's been around for decades. I don't see why there should be a problem with that.
So when all the modulation and protocols,
All open, all open.
can be shared.
Yes,
with the rest of the world.
all open.
China launches one a couple years.
If they want to, right.
Correct.
Right. Yeah.
Go ahead.
Oh, I've heard frequency hopping. What did you say before that? Oh, source coding. Well, source coding means compression, and I mentioned the codec 2 that Hammond in Australia. I mean, that's just one of our options. I think it's a very good one. There's a lot of them now, but we might as well use the one that was built by Ham for Ham use. It's actually very good compared to the commercial alternatives. What's that? Oh, frequency hopping. We're actually just talking about that. I think you could see that the design I'm coming up with is actually could be seen as slow frequency hopping, because you can transmit anywhere. You simply key up randomly anywhere in the band, and you will be heard as long as you don't step on somebody else. So yes, you could hop around, and we probably will. Okay. on the satellite, it doesn't need to go any higher than that because the satellite is like a link layer device. It demodulates the data you send up, turns it around, sends it back down. Everything else is interpreted on the ground. It doesn't care if it's voice or anything.
Yeah, there's some layering inside the radio going all the way on the ground. The Phase 4 radio is on the ground. But like he said, the satellite is essentially, we're talking about a pretty low layer, just like it would be terrestrially. And the other interesting layers can happen in the radio, as little or as much as you want. And then you had a question, sir?
I was wondering what the timeline is for the test bed for use the radio system.
Oh, yeah. Okay. So his question is the test bed for the GroundSat and for the AirApp. We're working as fast as we can to actually get it up and running and on Palomar and on Dixon. And I don't know, do you have an update, Kathy, about Dixon? Not this time. Okay. So they're actually ahead of us. So there's some friendly rivalry and competition going on. They actually have equipment on Dixon. I don't have anything on Palomar yet. They can be, yeah. We're looking at he's asking the 4 sites, the 4 GroundSat development sites. We're going to try to connect them via VPN so that we can quickly share updates and mess each other up, because we're competitive and all. The time frame is as soon as we can possibly find, with both hands. And the slide where we repeated the demo for the ARAP code literally just happened a couple of days ago. But we now have. No, we're talking weeks. And Mark actually is going to be super helpful to get us to beat Lake Dixon. I'm not competitive or anything. So does that sort of answer your question? As quickly as we can. The demo code, the code that's already loaded up in the USERPs is pretty low level, not very fully featured, but it works. So all the other stuff to make it work reliably and to work out all the kinks needs to start happening, and we need to get it up so that we can actually use it like a real radio. So we're working on it. I don't have a good date. We're talking like weeks and not months though, to try to get it up off the ground. Yes, sir.
Knowing what I know about the mountain, there's trees or vegetation affect there's 10 gigahertz is kind of obstructed by that.
Yeah, his question is vegetation on Palomar. Is that going to be a problem? Yes, it's a concern. Yes, I think it'll need to be high up. Alternatively, there's another property and I have a chainsaw. Yeah, this is actually round 2 of this particular project. Back in 2008, we tried to get another geosynchronous project going. I'm kind of glad we had the delay because the technology has come so far. We're able to put a lot more up on the tower in boxes as close as possible to the business end, and basically just run power over Ethernet or whatever up and down the tower. That's what we're hoping to be able to do. Any other questions? Yes, sir. No. HF will never die. He wanted to know if we're all going to be transmitting over satellites. Satellites, actually, the capacity is not really that big. It can't, unless we put up how many satellites would we have to put? A lot. Hundreds, thousands. I mean, I'd be happy. I love working on this project and all, but no, HF will never die. This is not a replacement.
Put up HF antennas, right? As opposed to a direct TV dish. There aren't any other antennas.
You had a question, sir?
How are you going to solve the collision problem on the uplink?
That's one of the things we're working. That's one.
You want to talk about that?
Well, I could go with it.
He asked, how are you going to solve the collision problem? And there's ways where it's usually done. And yeah, we're actively working on whether or not we can come up with anything even more clever than what other people have come up with.
Is the purpose of the aggregator so that we can use simple equipment like a handy talk?
Exactly.
Yes. Yeah, he asked, what's the purpose of the aggregator? Is this so that you can use, I don't know, Howard, what do you call them? Dumb radios? I don't know. legacy, so that you can use something called a legacy radio. I don't know what that is, you know, but no, the aggregator is so that you can use super expensive Phase 4 radios and talk through to the satellite. And it's also requested by FEMA that we do a demonstration for emergency communications, that we're able to suck up, you know, emergency traffic without them having to get any fancy radios, that we can serve the public by just sucking up the signals in a certain area and shipping them up. Yes, correct. Any other questions? Yes, ma'am. A power source?
Up there or down here?
You mean on the satellite? How you get your power? Do you know how they get the power? I hate space. I think it's solar panels. Ah, yeah. In the big silver box, or that big box that was behind us, you can actually see a mock-up of the panels on either side, almost as big as that big cube, as a panel that folds down, folds out when it's launched, and then it's charged up by solar. So that's how the overall satellite is getting its power, is through solar. Oh, you're welcome. Anybody? Yeah, I don't yet know about well, okay. For a prototype terminal, if you wanted to cobble something together today, you would have to go to like Demi, Down East Microwave, or in the German guy that sells all that cool stuff, and buy RF hardware that you would stick to a USERP. And then you'd stick the USERP to something like a Mac Mini or a Linux box. So if you add up all of that, plus your time and pain, then you would get a number that's in the low kilobucks. Our target for buying this as a manufactured item is $1,000, and that's pretty aggressive, but I've been told we can meet it if we're good. So that's not a huge difference between, like, you could spend $3,000–4,000 on your own development station for a Phase 4 radio, or $1,000 on something that's put together by some of the manufacturers that we've been talking about. Does that answer the cost question? Any other questions? Thank you.
Thank you very much. Couple of closing comments. A reminder about operating day on Saturday. Certainly want to see some folks out. Oh,
He's just arrived.
hot off the press.
Hot off the presses. This is
for
W6NWG.
yeah, W6NWG, the Palomar Amateur Radio Club. We've got worked all states. We were gathering information from the field days and uploaded it to Logbook of the World. And we have a worked all states in CW, and a worked all states in single sideband, and a mixed. So no, this is over several field days.
All be certified for the scope, and then there's some endorsement stickers in here, but they just were handed to me in tubes. That's why they're rolled up.
Why they're rolled up.
But we are paper chasing for W6NWG. If you work HF and you've already earned all of your awards that you want, then please talk to me about using W6NWG. And you can, and we can get more awards. So, challenge to the club. Let's get more of these.
Thank you. Operating day, a reminder, it is a club-sponsored function, so there will be tickets, participation points to those who show up. The same for the Rosecrans Day. Full disclosure, I will not be at Fort Rosecrans. It's a choice between that or the Army-Navy game in Washington, and I'm going to Army-Navy, beat Army. But that will have the participation points, and it should be a lot of fun. Kilo 6, Mike, Romeo, Mike. Mike, are you here? We have your name tag from the Palomar Club. And this December is our Christmas social. Look for the items in the scope. What was that? And the elections. That's right. Elections and social. So all will be in the scope, electronically delivered. With that, oh, I'm sorry, Dave. I forgot all about that. There you go.
Hey, I'm Dave, N8KBC. I am the Assistant Section Manager for the ARRL. How many are members of the ARRL? That's great. There's an election coming up in January. Ballots will go out on the 2nd of January for Section Manager. Steve Early has decided not to run. So I am running for Section Manager, and I believe Pat Bunsold is running for Section Manager. So I would appreciate your support. I've been doing this for a long time before I moved out here in Ohio, and like to keep doing it out here. Thank you.
Glenn will remember.
The lifetime membership, who was that for? Mike Pennington. So there's a request for Mike Pennington to be granted a lifetime honorary membership to PARC. And the board has already voted electronically and discussed it in person to go ahead and approve this. According to the bylaws, it is a membership decision. So we will vote on that as well at the next meeting, and there will be appropriate announcement in the scope. And Mark has something to say.
We can make this really short. How many people here know Mike or remember him? Okay, let me just tell you something real quick. Mike worked for the phone company. Just about everything that the phone company threw away, Mike grabbed. Mike is the reason why we have a little bit of some of the buildings we have. Mike is the reason why we have a battery bank. He not only got it, but I remember I still have the dolly with the rust all over it from the acid when we were putting in the batteries, almost 15 years ago. He built the battery array. He installed all the equipment. We helped him put the batteries up. He climbed up in there, put it all together, got everything working. If there's anyone that's deserving, because all he's asking for is access, to be a member of the club. If there's anyone that's deserving of it, he definitely is one of the people in my, he's moved to, Montana? So he's just done so much up on the mountain. His hands are, you can see him just about everywhere. So I just wanted those of you who don't know, who put a lot of that stuff together, not the radios, but the infrastructure that keeps all the radios going, it was Mike.
Okay, so that vote will be next month, and it'll be announced in the scope in accordance to the bylaws requirements.
That's it. We have some.
Oh, there are some cards for the Ford Rosecrans, ham radio outlet, candy catalogs, some magazines on the table here that probably don't want to go home, that want to go home with you. Yeah, make sure that you've all signed in. There's two orange clipboards back there that Joe is holding up, and make sure you've signed in and mentioned on there the little check mark that you are okay with the current distribution of the scope.
That's it.
That is it. Concluding at 21:04. Thank you, everybody.